So for this one here, what I'm given is a curve, and I'm given the derivative of the curve being dy by dx equals 8x cubed plus 3. I'm told it passes through a point. What I've got to do is express y in terms of x. So I want to work back to the original curve. Now, when we've got a question like this, we've been given the derivative and we work back to the original. What we want to do is we want to integrate that function. Now, if we integrate the function, we have to follow the same set of steps as we always do. Raise the power by 1, divide by the new power. And then we've got to remember and put our wee bit on the end, the plus c. So if we do that, and we just bear that little bit in mind, we know that y is going to be the integral of 8x cubed plus 3 dx. So doing that, what I end up getting is that y is equal to 8x to the 4 over 4 plus 3x plus the c, remember the constant of integration? So y is equal to 2x to the 4 plus 3x plus c. Good. So it wanted me to express y in terms of x. There's an issue here. That's not expressed in terms of x because I still have a c. We need to get rid of that. If it wants it explicitly expressed in terms of one other variable, we cannot have another variable in there. I.e., if it wants it in terms of x, that c invalidates it because that's a second variable. So we need to get rid of it. However, a question like this, where it wants it explicitly in terms of another one, needs to give us more information. And if you read the question, it does give us more information. It gives us that. It tells me the curve goes through that point. So it tells me that when x is equal to -1, y is 3. That's what that coordinate means. So I can use that fact and substitute that into the equation to be able to determine the value of c. So if I substitute y as 3 and I substitute x as -1, what I'll get is that 3 is equal to 2 times -1 to the power of 4 plus 3 times -1 plus c. So starting to simplify numbers, I get 3 is equal, well, -1 to the power of 4 is just 1, plus 2 times 1, which is 2. 3 times -1 is -3, so that's 2 take away 3, which is -1. So I know then that 3 is equal to c minus 1. So if I solve that simple equation here like that, I then get that c is equal to 4. So what I now have is I have now solved and got the constant of integration. So what that now means I'm able to do is I'm able to determine the explicit curve of y. So I'm explicitly able to express y in terms of x. And I have to do that. It's not enough at this stage to have y written in terms of x plus a c and then figure out the c. Great, I've got all the parts. But now I have to express it in terms of x explicitly. So what I then have to do is write that y equals 2x to the power of 4 plus 3x plus 4. What I've now done is I have it written solely in terms of x. There's no plus c in there anymore because I now have the 4. Now, with this sort of question here, this can actually be applied to curves just in general. So it's not just expressing y in terms of x. If you were to get to the plus c stage, so this stage here, what this represents is because the constant of integration is a plus c, it's just a generic constant at that point. It could take any specific value. So what it represents is actually a family of curves. It's not a single curve on its own. It represents a family of curves that take the format 2x to the 4 plus 3x plus c. And every value of c gives you a different curve. Specifying the point it passes through, the -1, 3, and finding c is equal to 4 tells me the specific curve it is, because it has to be the specific curve of that format that goes through a set point. Because it does that, I'm able to determine c and express y equals 2x to the power of 4 plus 3x plus 4 as my function. So y there is expressed in terms of x as a singular function representing one curve in space. This question here, worth 4 marks. You get 1 mark for integrating a single term. You then get a second mark for integrating the second term and putting the plus c. Now the plus c must appear at this stage here. The plus c must be there. If you add the plus c in later on, so I substitute and then somehow my plus c comes out of nowhere, I'll lose the mark because you've magicked out a plus c from somewhere. That plus c has to be part of your expression and your general integral at that point. Bear that in mind. Always add a plus c at the end of an integration just so you've got it in there. Third mark comes from substituting in to find c, so at this stage here, and then your fourth mark, as I've mentioned, is for writing y in terms of x as a final step, where we've got rid of the c and we've put the value in for it. Bear these steps in mind here. It's just a generic integration question. We've covered the technique to do. We've covered the finding the plus c before. We know the steps and we know how to do it. Just a couple of big things to remember is that plus c appearing and where it appears, how to substitute in the points, and then that last step of make sure you explicitly express y in terms of x. If you can remember all those little tweaks and your basic fundamental technique of integrating terms, you will smash this question and you will absolutely nail something of this format. No problem, and you'll find it easy peasy, lemon squeezy.